Good evening, everyone. My name is Eric DiMarzio, and I'd like to welcome you back to another Tech Talk in our series sponsored by Bracklet. Today, we have the pleasure of welcoming Paul Uhlenkott to give us a brief talk about state management alternatives. So, without further ado, I'd like to pass it over to you, Paul.
Thanks, Eric. And before I start, I would like to thank Bracklet for sponsoring this Tech Talk. Today, I would like to talk with you about state management alternatives that exist on the market today. Before we get into that, though, let's at least define some terms. I would like to start by talking about what is state. To put it simply, state is a way of representing our code at a certain point in time. So for example, a door could be locked or unlocked, and that could be its state at a certain point in time. So state management then is how we can handle state within our application. Ideal state management solutions should at least let us store default values, let us update these stored values, and then read values and give them to components that require them. So to go back to our previous example, we may have a door that starts out locked, and then when a user inserts their key, the door now becomes unlocked and can walk through the door as the state has updated. So let's take a look at a few state management solutions that exist on the market. We'll start with one of the more popular ones in Redux RTK, which provides a more centralized state solution that's great for large-scale projects. We'll take a look at Recoil, which is Meta or Facebook's React-specific solution. We'll then talk about Jotai, which provides a more minimalistic solution. And then finally, we'll end with Zustand, which provides a simpler centralized state solution. So let's start with Redux. Redux was developed in 2015 by Dan Abramov, originally to help him demonstrate how you can do time travel debugging in React. It soon would become one of the more adopted Flux-based state management solutions, and with the release of Redux Toolkit in 2019, it soon became an industry standard in developing applications. So let's take a detailed look at how we can implement Redux into an application. We'll start with a centralized store that has our current state and pure functions known as reducers. Then when a user would interact with our app, we'll dispatch an action to our store and alter our state using the reducers that we defined in the store. Once the new store has been calculated, we'll pass any changes to our UI to then update our components. So Redux has a lot going for it. As a central state to manage, it's very easy as our application scales to be larger and larger, and it is highly performant. It's also very popular, so you can expect that there's high community involvement and that Redux will stay up to date as things change. However, it does have a very high learning curve, and there can be a lot of boilerplate code involved. RTK has solved some of the learning curve and boilerplate code issues, but they're still relevant. Redux can also have some difficulty dealing with asynchronous code and does require middleware and extra support to make it work. Let's also discuss Recoil. So Recoil was developed by Meta, also previously known as Facebook, to be a more seamless, easier to use state management solution for React. It follows the philosophy of having individual components subscribe to smaller pieces of state called atoms, which will then get updated using selectors that are pure functions similar to reducers in Redux. So let's take a look at how we might implement Recoil. We will define an individual piece of state as an atom, and then components will subscribe to these atoms and update them using the useRecoil state hook, which is very similar to the use state hook you're familiar with in vanilla React. Then we can have selectors that will create and derive new atoms from our existing atoms that components can subscribe to just as the regular atoms. Because of its seamless integration with React, it's very easy to learn if you already are familiar with React's design patterns. And there's a very low boilerplate requirement to get started. However, it is React specific. So if you're planning to develop anything besides React, such as Vue, you're out of luck. It also doesn't support any sorts of middleware, and you're reliant on Meta to update Recoil to suit your needs. Because of that, there's very low community involvement and support. Next, let's take a look at Jotai. Jotai was created by Daishi Kato in 2020. He was inspired by Recoil's atomic nature and wanted to expand it to libraries outside of React. Its design philosophy is more around the atom itself as an isolated piece of state that can then be accessed throughout your application using hooks. So let's take a look at a simple implementation of a Jotai application. We will create some atoms that will store the simplest pieces of our state, and then we can derive further atoms as composites of our other atoms. Then these atoms can be accessed from anywhere using hooks. Because Jotai is so simple, it is very easy to learn, but don't be fooled, it does have a very robust API that can let you get more complex with it. It also has a very small bundle size in case space is a concern in your application. It also comes pre-built with some ways to persist data. However, because it is dealing with simple states rather than more complex states, it can get more complicated to use as your own state becomes more complex. And the lack of structure can lead to atoms being spread throughout your application and lead to some unpredictable state updates and can be difficult to debug. Next, let's talk about Zustand. Zustand was created by the Poimantris group and eventually finished by none other than Daishi Kato, who was the designer of Jotai. Zustand takes the central store methodology of Redux, but rather than deal with the whole dispatchers and reducers thing, creates your state as a hook that can then be accessed anywhere in your application. So let's take a bit of a look at a Zustand implementation. Basically, what we'll do is we'll create a central store with our state and desired functionality, then access that store and bind our components using the use store hook provided by Zustand. And that's it. That's all that's required. So again, we have a centralized state management, which makes it a lot easier to debug and manage because all of our state and actions are in one place. But it's also very low in complexity and boilerplate, making it very easy to get started. It also comes pre-built with some strong asynchronous support and asynchronous state updating. However, Zustand can become a bit more difficult to manage as your project scales up, and it does have a bit of an unusual approach that's not necessarily common among state management libraries, so it could present a learning curve for developers that are already used to other solutions. But there is a bit of a secret sauce here, is that while each state management presents its own pros and cons, none of them are precluded for being used together. So feel free to mix and match as your state management requires. So here is my works cited page. And I would like to take a pause to see if there are any questions. And if there are no further questions, I would like to thank Bracklet once again for sponsoring this Tech Talk. And back to you, Eric.
Thank you so much for that informative talk, and thank you everyone for coming out tonight. We'll see you at the next one.